Alright, the fourth and final lesson about this stuff about vectors is vector components or resolutes. They're known by either of those terms. I tend to think them about as talk of them as components. So in your notes there, as it says, just as two vectors can be added to give another vector can be split into two or more vectors. These are called components or resolutes. So you can see a couple of examples here. So this blue vector, we could split that into a couple of vectors. Those two would add up to give the same one. Oh, and there would be many others. Right, so you can go that vector and that vector. Okay, any vectors. This other one that's there, this red one here, again you can split that up in many ways. And here we've got four vectors that add up to it. All right, so that's kind of is a bit random, but for us and what we're doing, we don't want kind of randomness. We want things that are going to help us make things easier. And so for us, if we've got a vector, for example, that is pointing in this direction, and so we know that's north up the top there, then what makes sense is for us to split it up into a couple of specific vectors, like those two there, for example. So the green one, which is towards the east, so that would be the east or the easterly component, and the orange one would be in the northerly direction, so that would be the north or the northerly component of it. So if this is something that's saying moving from there to there, so from a start position to a final position there, yes, it has gone from there to there, but in relation to where it started, it's a bit to the east and a bit to the north. So for us, when we're doing that, because that's a 90 degrees in there, and then if we know things like, like angles here, then we'll be able to then work out those components. So let's have a look at a couple of examples. Alright, so in this one here, a cyclist rides a distance of 15 kilometres in a direction north 30 degrees east. Find out how far east the cyclist travels. So we start with our north up the page, and our cyclist has ridden 15 kilometres in a direction north 30 degrees to the east. So our cyclist has ridden in that direction there, so here's our north-south line, and he's north, so again there's our north, and so this angle in here will be 30 degrees, because of course east would be to the right. Alright, it's a bit of a dodgy vertical line that I've drawn there, but anyway, so let me just fix that up. So there's our north-south line there. Alright, so we're asked how far to the east. Now the east is pointing that way, so if we've already got that north-south line, so if I draw a vector from that north-south line to our final spot that makes a right angle there, then this component here is the east part. Alright, so that's the east part, and we want to work out what that east part is. Now, we've got a right angle triangle there, and east is the opposite side of that triangle, and the 15 kilometres is the hypotenuse. Opposite and hypotenuse would be sine. So the east component would be just simply 15 sine 30 degrees. And so the easterly component, or the distance east from the starting point, which was here, so yes, it's moved some north and some east, so the easterly component when you do that is 7.5 kilometres. Alright, there's one example. Let's look at another one. Okay, determine the perpendicular components of a 235 Newton force acting on a box direction 17 degrees north of west. Alright, so if here's our north-south line, east, west, south. So what I'm going to do is I'm going to draw here, because the angle is north of west, I'm going to draw a line here that's going, I'm not going to draw it in that colour, I'm going to do it in grey. I draw a line here that's east-west. Alright, so this vector is 17 degrees north of west, so say its starting point's there, and it heads north of west, so it's not heading that way. It's heading north of that, so it's heading north of west, and it's heading 17 degrees north of west. So it heads out there like so, and it's 235 Newton. So determine the perpendicular components. So what we're talking about with perpendicular components, I'll draw a line down here, and draw a line across here. Then there's a right angle in there, and they're perpendicular components. Alright, and so this component in the orange is the westerly component, and this one here in the blue is the northerly component. Alright, so let's squeeze this over in here. So the northerly component is, and put that in a very good spot. Let's move that. Oops. So north there. So the northerly component, well, that side is opposite the 17, opposite, and hypotenuse for the 235 is sine. So 235 sine 17 degrees. And when you do that, you get 68.7 Newton. And the westerly bit, and I'll do that over here, the westerly bit's adjacent, so adjacent is cos, so that'll be 2, not 3, 235 cos 17, and when you do that on your calculator, you get 224.7 Newton. Alright, so that is vector components. So all this stuff on vectors we will be using later on in this motion topic. So it's just about, this first bit has just been about working with vectors and how we add them, subtract them, etc. Alright, so that's problem set number 4 there, and so if I haven't already said, which I probably should have, is that we've got the first test on at this point. So that first test is it's on our problem sets 1 to 4 is what it's on. Alright, so it's all that vector stuff, and there's some revision as well. Alright, so anything that you are not sure of, make sure you ask as per usual.